Hello, AP Stats. Once again, this is the free response number 3 review. I'll go over the 7 questions that we did as of October 12th. There was one question that none of the groups got a chance to work on, and I hope that this video gives you a thorough walkthrough of all the different types of Chapter 4 free response questions you face on the FRAPI sessions or the test. Okay, so for number 2, people with acrophobia, fear of heights, sometimes enroll in therapy sessions to help them overcome this fear. Typically, 7 or 8 therapy sessions are needed before improvement is noticed. A study was conducted to determine whether the drug D-cycloserine used in combination with fewer therapy sessions would help people with acrophobia overcome this fear. Okay, so each of 27 people who participated in the study received the pill before each of the 2 therapy sessions. 17 of the 27 people randomly assigned to receive the cycloserine pill, and the remaining 10 people received the placebo. After 2 therapy sessions, none of the 27 people received additional pills or therapy. 3 months after the administration of the pills in 2 therapy sessions, each of 27 people was evaluated to see if he or she has improved. Okay, so it seems like they receive a pill and then they receive the 2 therapy sessions in countering the acrophobia and seeing how much of the improvement they have with these 2 types of treatments. Was this study an experiment or observational study? I think you guys can all agree with me that this is obviously going to be an experiment. Well, why is it going to be an experiment? Because we have randomly assigned a group of 17, I would say, participants to the treatment, D-cycloserine, and the rest, 10 participants, to a placebo. Then, because the study, actually, let's erase the then. Because the study implemented a treatment to its subjects, it will be classified as an experiment. Actually, just finishing that, I think that should do the deed. Okay, so part B here. When the data were analyzed, the D-cycloserine group showed statistically significantly more improvement than the placebo group did. Based on this result, will the researchers be justified in concluding that the D-cycloserine pill and the 2 therapy sessions are as beneficial as 8 therapy sessions without the pill? First of all, I'm not sure why this is happening. So without the pill means that you're not taking any of the drugs that was provided for here. When you just read this out loud, somewhere along the lines, you might be wondering, or more gearing towards to saying no, and you should be absolutely correct with that. So this is a no, particularly because the 8 therapy sessions without the pill, there's absolutely no information with that. Without the pill means it's more closely related to a control group. So you would say no because no data is present for 8 therapy sessions and no pill. Also, we simply cannot determine, based on this experiment, that the improvement on what is it, the acrophobia, I think it was a word. Yeah, acrophobia. Improvement on acrophobia is related to the pill or the therapy sessions. There was no control group at the beginning of this experiment to compare it to. Therefore, having 8 they want to say, would this research justify and conclude that cycloserine pill and 2 therapy sessions are as beneficial? Therefore, having 8 therapy sessions and no pill, therefore, I think I should say, therefore, one cannot say having 8 therapy sessions and no pill will necessarily be better or worse than having the cycloserine pill with 2 therapy sessions. So basically what this is saying is that you do not have anything to base it off of having no pill. Like you have 8 therapy sessions and no pill. Is that going to be necessarily better or worse than comparing it to 2 therapy sessions and having the D-cycloserine pill? Well, there's no data to measure that with. Like there's no control group to actually kind of compare it to. So therefore, this is simply no. There's not enough data to for us to say that with confidence. Part C, a newspaper article that summarized the results of the study did not explain how it was determined which people would receive the cycloserine pill and which received the placebo. Suppose the researchers allowed the therapist to choose which people received the D-cycloserine and which received the placebo, and no randomization was used. Always a bad idea. Explain why such a method of assignment might lead to an incorrect conclusion. Because no randomization is implemented, and we allowed the therapists to choose which participants will receive the pill or not, or placebo. The therapists could assign certain participants to receive the pill because of their severity of acrophobia. The personal input from the therapists by giving, I should actually rephrase this. So I'm going to put this a little bit, I don't want to grab the piece from the participants there. So personal input from the therapist, I'm going to put this at the very end. I can't really change this word, so I'm just going to erase the whole thing. By giving the therapists freedom to exercise which participants get the treatment, their own personal input could lead to a misleading data. So therapists, without any fault of their own, they could give much more severe cases of acrophobia to D-cycloserine when they observe them and kind of give them diagnosis. Oh my gosh, this person has a very severe case, so I'm just going to give them D-cycloserine pill because they might need it, just because they might need it more. And that could cause some misleading conclusions, because what we want to do is you want to simply randomize the subject and see, not depending on the severity of the case, we want to get a mix of those: severe, not severe, moderate, and then we want to give them the pills to see how it improves along with the therapy sessions. By giving the freedom to exercise that right from the therapist, their input, their personal inputs, and how they tweak things could lead to a misleading data, and that's what you want to say for part C. Okay. Obviously, having no randomization used was obvious key here, but you want to talk about in terms of context of what the researchers could potentially do. Give the pill to more severe cases of acrophobia just because they're therapists, right? I think something of that nature that you could think about. All right, so for number 2, let's take a look at the response to the nutrition concerns. Food served in school cafeterias. We have Healthy Alternative Meals Ham Company. Under this contract, the company plans and prepares meals for 2,500 elementary, middle, and high school students with a focus on good nutrition. The school administration would like to survey the students in the district to estimate the proportion of students who are satisfied with the food under this contract. So we have elementary, middle, and high school. 2 sampling plans for selecting students to be surveyed. One of them being, I believe, a simple random sample selecting 200 out of the 2,500. Remember the magic 3 sentences for SRS. First, assign each student number from 1 to 2,500. That's the first sentence always. Next, use random number. So I'm just going to say then, comma, use a random number generator to generate 200 numbers from this list. The students that were selected then would be given to, the students that were selected then would be given a survey to answer about whether they were satisfied with the food under this contract. So I'm just quite literally copying and pasting the last sentence of the prompt here to there. Okay, and so that's a simple random sample for A. Part B, if a stratified random sampling procedure is used, give one example of an effective variable on which to stratify in this survey. I would stratify the students based on their school level. So we are talking about elementary, middle, or high. This is because the opinions from the youngsters to preteens to teens could vary greatly based on their age also. So this is because the opinions from the youngsters to preteens to teens could vary greatly, and it's because the let's say the teenagers, because the teens could be more selective and picky with the foods they were given and could voice their opinions a little bit more strongly. Compared to the younger students. Students' opinions. So for part B, what you want to say is that the high school students would be much more picky in terms of what type of food they eat. And you can think of this realistically. They might complain about the school lunches, how bad it is, and voice their opinions much more strongly than compared to, let's say, for elementary school kids. For them, it's just about, eating the foods that was given to them. And then even though they might have some opinions, they might not voice it as strongly as how the teenagers. And teenagers' taste buds works a little bit differently than how kids would be, right? So that is the reason why we would stratify based on their grade levels in the schools that they're coming from. And part C, describe one statistical advantage of using a stratified random sample over a simple random sample. We would be able to see the opinions from the stratus, high, middle, and elementary, and make more, I would say, accurate conclusions as to how students feel about the new, I think, new nutrition, new food under this contract, whereas the simple random sample yields the general opinion from the students. I think the word that I'm looking for is also, we will be able to see the specific opinions from the stratus, high, elementary, and middle. We will be able to clearly see and note what they would say individually from each of their stratus, younger to older, and make more accurate conclusions as to how the students, based on age, would feel about the new food under this contract, whereas the SRS only just gives you a very general opinion, which will give you to a certain degree an idea as to how students feel, but it's not so specific and it's not advantageous as compared to the stratified method here. Okay, all right, so that's number 2, and let's talk about number 3. A local school board plans to conduct a survey. So we have 500 of these families who have at least one child in an elementary school. A proposal has been submitted that would require students in the elementary schools to attend a school on a year-round basis. So pretty much no summer vacation. Do you support this proposal, yes or no? The school board receives the responses from 90 of the families, which means 402 decided to not answer this survey, with 76 of the responses indicating support for the year-round schools. Based on this outcome, the local school board concludes that most of the families with at least one child in elementary school prefers years-round schooling, which they shouldn't have done. What is a possible consequence of a non-response bias for interpreting the results of the survey? Well, think about what's non-response does. You have 402 families that did not respond, which means that you're not representing everybody. Well, it's a sample of 500. You're not getting enough data from this. The only thing that you could probably tell is that vast majority of the families, they simply don't care about this prompt. The possible consequences of non-response bias is the fact that not all the parents' opinions, voice, and opinions are shown through this survey. It is a classic example of undercoverage because the 98 families that responded are generally more inclined to say yes, because if you are one of the families that promptly responds to these surveys, you might care about the child's education a lot more compared to the 402 families that did not answer the survey. Therefore, it is an overestimate of the percentage of families in favor of this survey. Okay, so it's an overestimate because obviously 76 out of 98 is a huge number. But those 76 out of 98, well, those are the family members that care more about the child's education, so they might just want the kids to go to a year-round school with no breaks, just because they want to get ahead in the education paradigm. Whereas the 402 family members that did not answer simply because they don't care, or they never received the message, or they just forgot to respond. It's not, you can't make really valuable conclusions out of this type of situation. For part B, someone advised the school board to take an additional random 500 families and combine the results. Would this be a suitable solution? Absolutely not, because it still does not solve the non-response bias presented in part A. There is no guarantee that the next 500 will all answer the survey. And it could lead to more under coverage and more non-response bias. Quantity is not the solution here. So let's talk about C. How will we solve this problem? So what you could do is make the survey mandatory, or go to each family's households to get their opinions in person or via phone/email. So what you want to do is you want to actually get these tangible results by forcefully getting out of your shell and then reaching out to them in a more aggressive manner. Reach out to the families in a more aggressive manner so that, well, actually, if you're going to become like, not aggressive manner as in like being aggressive, but like much more like out there and reaching out to them so that more opinions and voice is taken from the families. The whole reason why we want to do that is because so that we can just simply get more data from the people who failed to respond to this survey. We can make it mandatory. We could make it for a grade. That's another great solution for to the families. You got to do this survey, or otherwise your child is not going to get a good grade, or it's just for some consequences. Things like that will propel the student or the human behaviors to act in certain ways there. Okay, so that should take care of number 3, page number 3, let's say. And now we're down to, we're on the about halfway there, page number 4. Manufacturer of boots plans to conduct an experiment to compare a new method of waterproofing to the current method. The appearance of the boots is not changed by either method. So we're talking about 2 different types of waterproofing methods. 100 volunteers in Seattle wear it rains frequently to wear the boots as they normally would for 6 months. At the end of the 6 months, the boots will be returned to the company to be evaluated for water damage. Describe a design for this experiment that uses 100 volunteers. Include a few sentences on how this would be implemented. So first of all, you start with 100. I always like to first come up with some sort of a design and like an outline for this. So, okay, so we want to find out how we would be divide these 100 volunteers so that the waterproofing to non-waterproofing, that those are going to be, or the different water type proofing methods, it is what we want to compare. So explanatories here should be the waterproofing, and there are 2 types, let's say A and B, versus the response is the damage to the boots. So, what I would do is, you can divide up into 2 groups or 3 groups, but what I would do is I would divide them up into 3 groups. Whereas, I think you could go in many different ways here. I feel like the first group could be the group that uses the boot frequently. So it really depends on the job, right? So how many hours do you use the boots to work? Okay, so let's say on a given 40 to 60 hour workload, about more than 55 hours, you wear the boots on a weekly basis. Uses the boots moderately, could range anywhere between 35 to 55 per week, and then uses the boot rarely, would be less than 35. I'm sorry, X is less than 35, which means be like this, 35 per week. So 35 hours per week, less than that, between 35 to 55 will be second group, and 55 hours per week, so that will be the first group. So you would divide those groups up like this, and could be like 33, 34, and 33, give or take. Then you would use 6 months, wait 6 months for all of these groups, and then measure the damage in the boots. So first, the design here should be, we are going to have block the volunteers by the amount of time spent wearing boots to work, to any other activities. So we want to separate them by the amount of hours they spend, because the more hours we spend, that could be a confounding variable as to how much damage it could be done. It's not just about the waterproofing, right? Then use random number generator 1 through n, because we do not know what n is. We could have 33, 34, 33. It could be any numbers, right? So from 1 through n, we would separate them and then say that I'm sorry, wait a minute. So we use random number generator to randomly assign them to, oh, I forgot to do one thing, because there's going to be 2 treatments to each of these things. And I'm going to move this just a little bit to the right here. Okay, so we're going to be given 2 types of treatments, right? We're going to be given the new method, the old method. We're going to give you the new method and the old method, new method and the old method. So this is where you actually split into 2. So then use a random number generator, assign about half from the first group to be given the new waterproofing method. Okay, and the other will be given the old waterproofing method. And then for the comparisons, I believe we just have to compare it this way. These two, these two, these two. We wait 6 months for all of these. And then compare all the damage that's done to the boots that will be given the water over the, then wait 6 months. Then compare the damage in each new and old group for each of the 3 blocks. So for the 3 blocks that we have, we based it off of the amount of boots that was worn. Then we can assign half of them to be new and old, new and old, new and old, and then we can compare after 6 months, like what happens afterwards. Okay, all right, so that should be for part A. And now for part B, I'm running out of space. Could your design be double blind? I will write my answer here. So for this one, what you want to say is yes, because double blind simply means that neither the experimenters or the subjects know what type of the treatments they're going to be given. So treatment tier is obviously this. So if they know, like if the subjects know that they're receiving like the new pairs of boots, they might actually tend to wear it a little bit more, or they might just subconsciously just say, oh yeah, I'm having this new waterproofing method, so it must be more durable, or it must be more physically stronger than the older one, just because it's newer version. So yes, this could be double blind. because the treatment receiving the new and the old should be, or actually because this is asking for could your design be double blind, because the treatment can be not known to the subjects nor the experimenters. So because we say double blind means not only the subjects do not know, the people who are actually giving the boots, they don't know either. So I'm running out of space to write this, but I'm going to extend it here and just try to write it here. So if it's double blind, the experimenters nor the subjects know which boot is the new waterproof, or old. This might eliminate some potential behavioral issues that may occur from the subjects or the experimenters once they know the type of waterproofing. So for example, like the one that receives new, they might go through the normal wear, and they might wear it more harshly because they feel like they can use it in a multiple instances, and because it's new, you feel like, oh yeah, because these are new waterproofing, it should be able to withhold all of these damage. Or they could try to like use it less because, oh yeah, I want to save this, and I don't want to create any damages to this. They might have that sort of idea. If you give the experimenters the power to assign, or they know which waterproofing method the boots have, then they might give the one to a person who might need it more. That could be a potential input that the researchers could put in, or experimenters, and that's not the right conclusion that we want to make it off of. So double blind, if the question is asking for could be, yes, absolutely, which could eliminate any potential inputs from the experimenters or subjects. That's the whole purpose of double blind. Okay, so sorry, my handwriting is just all over the place. I'm really running out of space to write this, but that's probably what I would write down along those lines right there. Number 2, at a certain university who live in dormitories dining hall, recently some students have been complaining about the food quality. The dining hall manager decided to do a survey, proportions of the dormitory who think the quality of the food should be improved. So this is the prompt. Many students believe that the food served in the dining hall needs improvement. Okay, so very subjective sentence in the very beginning. Do you think that the quality of food served here needs improvement, even though they would increase the cost of the meal plan? Now, the last sentence, they might gear their behavior towards some other direction. In this setting, explain how the bias might have introduced based on this convenience sample was selected. We select the first 100 students entering the dining hall to answer the following question. Okay, so because we selected the first 100 students, first 100 student that entered the building, they might tend to have higher opinion about the food because they get the highest quality food served in the I believe dining hall. when you get there early in the dining hall, all the foods are not taken. All the ingredients are much more fresh. Everything's in stock, and you can just pick out whatever you want. So they might have a higher opinion about the food in the dining hall because they get the highest quality food served in the dining hall. So how would you be able to actually solve this problem and to avoid this bias? Just to take a random sample, I will take a systematic sample honestly for this. So select a number. For instance, this is since 3, then systematically choose every third person coming in to the dining hall to voice their opinions. Okay, so first, and also students who live in dormitories eat at a common dining hall. Recently, some students have been complaining about the food qualities there. Now, if you only actually voice the opinions about the students who come into the food dining hall, then we're actually forgetting about the students who actually do not come into the dining hall at all. So also, we want to get a sample of students who do not come to dining hall. So take simple random sample of size n from the dormitories as well and get their opinions. And I'll just stop there. Okay. So basically how you want to solve this is for the dorm people who are coming into the dining hall, you can take systematically, or you can just assign everybody a group number from 1 through whatever, and then take a simple random sample if you want to do that. But also at the same time, it's imperative that you also mention that the people who do not come into the dining hall, the people who just don't feel like eating at the dining hall at that specific day, they go to the dormitories, and you might just knock on the dormitories and say, you know what, we're just going to check the clusters of fourth floors, or the even numbered floors, or we could take every other room for dormitories and ask the students who live in those dorms to voice their opinions and things like that, and basically want to involve the people who comes into the dining hall or doesn't, and get everyone's opinions intact. Part B, in this setting, explain how the bias might be introduced based on the way the question was worded. So the question was worded in such a way, and I'll use blue for part B here, in such a way that the first sentence pushes for yes, whereas the last sentence pushes for no. This could lead to question wording bias. Okay, so question wording bias means based on how you worded it, many students believe that the food served in the dining hall needs improvement. Now, if you see that, because many students believe it, you might want to become the part of the majority. As human nature, we don't want to fall behind from the rest of the pack. We want to voice our opinions based on how majority of us think. It just makes us feel safer that way. But when you say, even though that would increase the cost, now you're involving cost into the picture, and then their opinions may be dictated by, oh, okay, so then how much money would that be? So these two sentences, if you exclude them, this is the only sentence that should be involved in this survey. Do you think that the quality of the food served in dining hall needs improvement? That's all you need to say. No, gearing towards one side or the other, favoring one outcome over the other. It's neutral. It's fair. it's on point, like that's all that you want to know, without mentioning the cost, without mentioning what the vast majority of the people think, which could lead to some bias there. Okay, so that is how you would fix the questioning wording bias for part B. Okay. All right, so let's do page number 5. An administrator at a large university wants to conduct a survey to estimate the proportion of students who are satisfied with the appearance of the university buildings and the grounds. The administrator is considering the 3 methods of obtaining a sample of 500 students from the 70,000 students at the university. Because of the financial constraints, the first method the administrator is considering consists of taking a convenience sample. Okay, so we ask the first 500 students who enter the stadium, why might the sampling method be biased in producing an estimate of the proportion of students who think they are satisfied with the appearance of the buildings and the grounds? The first 500 students who enter the football stadium might be students who show strong school pride and spirit, which consequently could mean that he or she is more likely to overrate the school Actually, I don't think I need to write down the because I think you guys can understand showing more school spirit, showing much more school pride, they might tend to judge the school in a much more favorable manner. So he or she is more likely to overrate the school, and that is the problem. And it doesn't really voice the opinions properly based upon everybody in this situation. Okay, so let's see if I could just do this. Okay, so for part B, because of the large number of students at the university, the second method the administrator is considering consists of using a computer with a random number generator to select a simple random sample of 500. So again, whenever they ask you for a simple random sample, just remember the magic 3 sentences. The first one is to assign a number from 1 to 70,000 to all the students listed. That's the first thing you need to do. Just give everybody a number. Then use random number generator to produce 500 of the numbers listed. These numbers will be matched with a specific student as described above, and give each of the 500 students the survey. Okay, so that should be a way to go for the simple random sample. Always assign them numbers, use a random number generator, and give them the survey and measure and compare. Part C, because the stratification can provide a much more precise estimate, what we want to do is we want to stratify them based on 2 things. Then they're asking you whether it's going to be a gender or whether it's going to be of the 2 campuses with stratification by campus. So which of the following would provide a more precise estimate of the proportion of students who are satisfied with the appearance of the university buildings and grounds than stratification by gender? So they're asking you under what circumstances would stratification by campus would be much more advantageous. So if campus, or I would say if the 2 campus Campus has significant difference in terms of their overall appearance, because what we want to do is we want to measure the students' opinions about how they feel about the school, proportions who are satisfied with the appearance of the university buildings and the grounds. So if the two campuses have significant differences in terms of their overall appearance, then stratifying the students based on campus is the right thing to do. Because the students at a campus with much more pleasing aesthetics could rate the school's appearance in a more favorable outcome compared to the students who live on campus that does not have such aesthetics. The homogeneous group here would be the fact that all students are living in campus A, let's say, campus B, and let's say campus A has much more pleasing buildings and much more beautiful buildings, then their opinions should all kind of be around the same page, that it's a little bit more favorable and they might overrate the school. Whereas when they're living in a campus that's a little bit less eye pleasing and a little less beautiful, then they might judge the school in a much more unfavorable manner. So that's why we want to stratify based on the two campuses rather than gender. Yes, the boys and girls might feel a little bit differently about how the colleges are, but it wouldn't differ so much in terms of how they feel in terms of their gender. It would feel based on where they live and what campus buildings they see. And I think any of these things would be, I think I said it out loud as well, but since I really don't have the space to write all those down, I want you to have to a certain degree what I just told you guys about the aesthetics in the two buildings and how that could impact how the students might voice their opinions about. Okay, so now down to our last two questions. Oh boy. So the apartment building has 9 floors and each floor has 4 apartments, and we have children in the apartments with the asterisk, and we have 9 floors. So for convenience, the apartment building owner wants to use a cluster sampling method in which the floors are clusters to select 8 apartments. Describe a process for randomly selecting 8 different apartments using this method. Okay, so since every floor has 4 apartments, it means I need to have 2 floors. So the owner could randomly choose 2 numbers from 1 through 9. Then the 2 numbers chosen will represent the floor number, and the owner will select the 4 apartments in each floor, yielding total of 8 apartments for cluster sample. Okay, so that's how I would do cluster sampling. You can just pick 8 by picking 2 floors randomly, and then you would just take the clusters of those 2. Part B, an alternative sampling method would be to select stratified random sample of 8 apartments, where the strata are apartments with children and apartments with no children. A stratified random sample of size 8 might include 2 randomly selected apartments with children and 6 randomly selected apartments with no children. In the context of the situation, give one statistical advantage of selecting such a stratified sample as opposed to a cluster sample of 8 apartments using the floors as clusters. So we're talking about one statistical advantage of doing a stratified random sampling. A stratified random sampling would mean that, for example, we could have 2 randomly selected apartments with children and 6 randomly selected apartments with no children. Stratified random sampling guarantees, I guess this is the most important word, guarantees at least one apartment with children. Because the building has a substantial amount of apartments, substantial number of apartments with children, it is important to have it included in the sample. Cluster, on the other hand, could yield 8 apartments where none of the apartments has children in them, which inaccurately represents all the residents in the building. Okay, so because the children are not properly represented, if I were to select, let's say, 6th floor and 9th floor, oh, actually, 9th floor has two apartments with children in it. What about 3rd floor and 6th floor? I mean, you can take a look at how all of these apartments have absolutely no children in them. Then does it give you enough evidence to say that this building has absolutely no children? Absolutely not, because we have 9 apartments that has children in them. We're not giving them correct representation. Therefore, by doing a stratified, the one statistical advantage would be that it's guaranteed to have at least one apartment to have children in it to correctly represent all the residents in the building. I think that would be the best way to put the answer for part B here. Okay, so I think that wraps up that, and now we're down to number 7, or page number 7 here. So what are we doing for this one? Researchers who are studying a new shampoo formula. We have volunteers, there's 12 of them. We have age, we have gender. These researchers want to conduct an experiment involving the 2 formulas, new and current, of the shampoo. They believe that the condition of their hair changes with age, but not gender. So we do not really care about the gender for the first one, because the researchers want to size blocks and experiment to be equal. They will use block size of 2. So we will have 6 blocks here. So identify the volunteers by number that will be included in each of the 6 blocks. So if we're depending on age, it means that we want to pair them up as closely as possible. It seems like 1 and 2, 10 and 11, 8 and 9. 2 oldest ones are 61, 16, 62, 16, 58, and 40 and 46 would be the other blocks. So we will have 6 blocks, 3, 4, 5, and 6. So these blocks will be paired with 21 and 20. Next one is 23, 24. Next is 44 and 44. Next is 46 and 47. Next should be 58, 61. Last one is 60. Oh, I should do 61 and 62, and that should be 60 here. So 60 and 58 should be paired. 62 and 61 should be paired. So you're pairing them based on the proximity of age. Identify the volunteers by number that would be indicating each of the 6 blocks and give the criteria. So the blocks are based on the proximity of the age between the 2 volunteers. So we can call these the youngest, these, I would say, the middle age, and these would be the elderly. So we would just group them based on 3 criteria like that, and then we could pair them up into additional 2 blocks based on how close they are in terms of their age. We will pick the 2 closest age to them, and then those will be your groups or your blocks. Other researchers believe that the hair condition differs with both age and gender. These researchers will also use block size of 2 in their experiment, identify the volunteers. So the very first thing you must do is to separate them by male and also by female here. Okay, so for male and female, we have, first of all, let's write down all the numbers for male. So we have 21, 47, 61, 58, 44, and 23. So it seems like the 21 has to be paired up with 23 here. So 21 and 23. Then we have 44 and 47. Then we have 58 and 61. So these two would be the age number 6 and 7. I mean, the voluntary number. 44 and 47, that would be 3 and 9. And 21 and 23 would be 1 and 11. I think I forgot to do that for these guys as well, so I'll do this. So 21 and 20 would be 1 and 2. 23 and 24, that would be 10 and 11. What's next? 44 and 45 will be obviously 8 and 9. These are the voluntary numbers, by the way. 46 and 47, that would be 3 and 12. 58 and 60 would be 4 and 7. And 61 and 62 would be 5 and 6. So each of these would be how I pair the volunteers by. And so then these 3 will be the male volunteers. Now I'm going to use a different color for females. Females, we have 20 with 24. Then the age, next group will be 44 to 46. The other age group will be 60 to 62. And so those would be 20 to 24 would be 2 to 10. 44 through 46, that would be 8 and 12. And then 60 and 62 is 4 and 5. We include 6 blocks and give the criteria used to form the blocks. Well, these would be the male, and then male and also proximity in age. And these would be the female, also proximity in age. All right, so part C. Researchers in part B decide to select the 3 of the 6 blocks. 3 of the 6 blocks to receive a new formula, to give the other 3 blocks the current formula. Is this an appropriate way to assign treatments? Absolutely no, absolutely not. So what that means is that you select 3 blocks, so block 1, 2, and 3. Like I select randomly, it happens so that I get all the 3 blocks with the males in them. Then I give these people the new formula, and I give all the female the old formulas. What's going to happen? Like now the hair condition is now going to be confounded by whether it's going to be based on gender or based on the formulas. So for no, so you want to answer this question with, first of all, no, because each block needs to have 2 treatments applied. So describing a method for selecting the 3 blocks to receive such formula. So for, let's say, what I would do is I would select a